Hello, good morning, 8th grade. This is Mr. Rogers, and you're watching the video lecture for Lesson 3-4 on Bernoulli's principle. This is our last kind of dead scientist of the chapter and his principle on how we use force and fluids here. And so our objectives today, just one, are to be able to explain and apply Bernoulli's principle to flight, how things fly. So Bernoulli is right here. Here's our guy. And Bernoulli lived again in the 1600s, a long time ago. And he had this idea, after many experiments, and it says, or states, that the pressure exerted by a moving stream of fluid is less than the pressure of the surrounding fluid. And so it seems kind of like a simple idea. Let's try this again. Bernoulli said that the pressure exerted by a moving stream of fluid is less than the pressure of the surrounding fluid. So what Bernoulli is saying, again, this was hundreds of years ago in the 1600s, he said that moving fluid has less pressure. And that's the biggest thing. Air, water, whatever it is. Moving fluid, and fluids can be liquids or gases, has less pressure. So moving fluid has less pressure. That's the big idea. That simple idea is what takes planes into flight, helps birds fly. Even why they have spoilers in the back of a car, kind of go in the other direction. It also explains how propellers work on boats. It's using Bernoulli's principle that moving fluid has less pressure. And that's the big idea. So I have a short kind of animation explaining this with a picture in a video I'm going to attach to this lesson. So 8th grade, we're going to stop here. Keep watching. I would probably write down what you see on the picture, in the picture also, as I'm explaining it. So I would continue to write that down, even though I didn't put it on this page. I would put down the definition and then keep writing what I put down also. So thank you for watching, and we'll see you guys along the way.
Hello 8th grade, this is Mr. Rogers, and we are discussing Bernoulli's principle. And what you can see in front of you now is a picture of a wing, so kind of a cross section. So we took a wing, cut it in half, and now we're looking where we cut that wing in half, like an airplane wing. And there's some things already on here we're going to discuss. And what we can see from the picture is, we can see, it says here, air moving over the wing has a greater distance to travel. So when it hits the wing, you can see it's going to go up, and then some of the air also is going to go down. And so the air that's going over the top of the wing, since it's curved, that curvature of the wing, it has to travel farther to make that trip from one end of the wing, the front end over here, to the back end of the wing over here. So air going over the top has to travel farther than the air going underneath, where it's just a straight line. And so what this does, again, it creates that difference in pressure because, like Bernoulli said, moving fluid has less pressure. And so the faster it goes, the less pressure there is. So the air over the top is moving faster, and like it says there, it's creating less pressure, or low pressure. And so what that does, the arrows are kind of showing this here for us. You can see the arrows here. We have more force pushing up here than there is pushing down. Make some smaller arrows here because of that. So what that is doing is creating that lift. We say airplanes have lift. When they take off, you have to create enough lift. And that's that upward push. There's a big enough difference between the pressure above and below. So above the airplane wing there's lower pressure, and above the wing there's lower pressure, and below the wing there is higher pressure, and that creates the lift. When that pressure is great enough below, it creates that lift, and the airplane takes off, or the bird flies, whatever it might be. So this very basic wing design is what allows us to do that. So the faster that air goes over the top, that lowers the pressure above the wing and allows that higher pressure from below to push up. And that's the idea of Bernoulli's principle and how an airplane flies. Same idea for a bird wing is shaped the same way. Even propellers on a boat have that curvature to kind of create this effect with a propeller. Even if you look at a spoiler on a car, why do cars actually have spoilers like race cars? This wing would actually be flipped upside down and do the opposite. So now we'd have higher pressure pushing down to stabilize the car, and that's why they do it. So 8th grade, we're going to stop there. I thank you for watching, and we'll see you along the way.